Question 1. For each item, drag it to the universally correct definition. Each item may be used once, more than once, or not at all. Represents data passed into a flow. Correct match. Inputs. Represents executable units that process data or perform tasks. Correct match. Nodes. Represents data produced by a flow. Correct match. Outputs. Prepares prompts as strings for complex scenarios or integration. Correct match. Prompt tool. Enables custom prompt creation utilizing large language models. Correct match. LLM tool. Allows execution of custom Python scripts. Correct match. Python tool. Now let us walk through the reasoning. Let us start with inputs. These represent the data that enters a flow at the very beginning. In real use, this could be a user message, a file, or a parameter passed into a workflow. Therefore, inputs define what information the flow starts working with. Next, we move to nodes. These are the executable components that actually do the work. For example, a node might call an API, run logic, or invoke a model. Consequently, nodes are where processing and actions take place. Now let us look at outputs. These are the results produced by the flow once execution completes. In practice, this could be a generated response, a transformed dataset, or a final value returned to another system. Here is why the prompt tool fits. It is responsible for preparing prompt text as structured strings. This is especially useful when dealing with complex scenarios or integrations that require reusable prompt content. Let us understand why the LLM tool is correct. This tool enables direct interaction with large language models. As a result, it supports creating and executing custom prompts that generate intelligent outputs. Finally, let us see how the Python tool works in real use. It allows the execution of custom Python scripts within the flow. This makes it ideal for advanced logic, calculations, or external API calls that go beyond built-in capabilities. Question 2. Fill in the blanks by selecting the correct options from the drop-down menus. Chat flow is tailored for conversational apps. Standard flow supports general LLM application development with versatile tools. Evaluation flow focuses on performance assessment using the feedback on previous runs. Now let us break it down clearly. Let us start with chat flow. This flow is designed specifically for conversational applications. In real use, this means handling multi-turn dialogue, maintaining context, and responding naturally to user input. Therefore, it fits scenarios like chatbots and virtual assistants. Next, we move to standard flow. This supports general LLM application development. As a result, it provides flexibility to combine different tools and logic for a wide range of use cases beyond simple conversations. Now let us look at evaluation flow. This flow is focused on measuring and assessing performance. Consequently, it is used to test how well models or flows behave under different conditions. Finally, let us connect this to feedback on previous runs. This mechanism allows results from earlier executions to be analyzed. In practice, this helps improve quality, compare outputs, and refine performance over time. Question 3. For each statement below, indicate whether the answer is true or false. Fine-tuning always requires more compute resources than training a new model. Correct answer? False. Prompt engineering can involve modifying the system message sent with the prompt. Correct answer? RAG-E is useful for grounding responses in specific factual data. Correct answer? True. Fine-tuning is primarily used to enforce tone and response style consistency. Correct answer? True. Now let us look at the logic behind it. Let us start with the first statement. Fine-tuning builds on an existing pre-trained model. As a result, it typically requires fewer compute resources than training a model from scratch. Therefore, this statement is false. Now let us move to prompt engineering. Adjusting the system message is a core part of guiding model behavior. For example, setting instructions about role or tone directly shapes the output. Consequently, this statement is true. Next, let us connect this to RAG. Retrieval augmented generation retrieves relevant information before producing a response. This ensures the model uses specific and factual context. Hence, this statement is true. Finally, let us understand fine-tuning in practice. Fine-tuning is often applied to enforce consistent tone and response style across outputs. In real-world scenarios, this helps align model behavior with organizational standards. Therefore, this statement is also true. Question 4. Fill in the blanks by selecting the correct options from the drop-down menus. In Azure, a base model can be selected from the model catalog within the Azure AI Foundry portal and then integrated into a chat application. After customization steps are complete. Now let us walk through the reasoning. Let us start with the model catalog. This is the curated place where base or foundation models are selected. In practice, it allows users to browse and choose the appropriate model for their solution. Therefore, this fits the first blank correctly. Next, we move to the Azure AI Foundry portal. This portal is where models are selected, customized, and managed. As a result, it logically completes the second part of the statement. Finally, let us connect this to a chat application. After customization, models are commonly integrated into chat applications for real-world use. Consequently, this completes the final blank accurately. Question 5. Fill in the blanks by selecting the correct options from the drop-down menus. A layered approach to mitigation spans the model layer, the safety system layer, the system message and grounding layer, and the user experience layer. Now let us break it down clearly. Let us start with the model layer. This layer focuses on the core model choice and its inherent capabilities and limitations. In real use, selecting an appropriate base or fine-tuned model helps reduce risk from the very beginning. Next, we move to the safety system layer. This layer introduces platform-level safeguards such as content filtering and policy enforcement. Consequently, it acts as a protective boundary around model behavior. Now let us look at the system message and grounding layer. This layer shapes how the model responds through instructions and grounded context. As a result, it helps guide outputs toward accurate, safe, and relevant responses. Finally, let us connect this to the user experience layer. This layer addresses how users interact with the application. In practice, it includes UI controls, feedback mechanisms, and user-facing safeguards that further reduce misuse. Question 6. When comparing open source and proprietary foundation models, what is a key advantage of proprietary models? Select one answer. A. They allow unrestricted code modification and on-premises training. B. They are typically free to use without any licensing requirements. C. They offer reduced transparency but lower overall precision. They provide enterprise-level security, technical support, and state-of-the-art accuracy. The correct answer is D. They provide enterprise-level security, technical support, and state-of-the-art accuracy. Now let us walk through the reasoning. Let us start by clarifying the nature of proprietary models. These models are delivered as fully managed services. As a result, they include built-in enterprise security, compliance controls, and professional technical support. Now let us look at performance and reliability. Proprietary models are trained and maintained using large-scale infrastructure. Consequently, they often achieve state-of-the-art accuracy suitable for enterprise and production workloads. By contrast, unrestricted code modification and on-premises training are advantages typically associated with open-source models. Similarly, being free to use without licensing does not apply to proprietary offerings. Therefore, when we connect everything together, the key advantage of proprietary foundation models is their enterprise-level security, strong support, and high accuracy. Question 7. A product team is building an internal help desk agent. The model sometimes answers convincingly but cites outdated or irrelevant facts. The team wants domain-specific, accurate answers pulled from their corporate repositories. What design change best ensures the agent's answers are based on relevant factual data? Select one answer. A. Increase the model's temperature to improve creativity. B. Perform additional pre-training on general internet text. C. Use prompt examples without adding external data sources. D. Adopt a retrieval augmented generation approach. The correct answer is D. Adopt a retrieval augmented generation approach. Now let us walk through the reasoning. Let us start by identifying the core problem. The agent sounds confident but relies on outdated or irrelevant information. Therefore, the issue is not fluency, but lack of grounded, domain-specific data. Now let us look at retrieval augmented generation. This approach retrieves relevant information from corporate repositories before generating a response. As a result, the model is grounded in up-to-date factual context rather than relying only on its general training. By contrast, increasing temperature affects randomness and creativity. It does not improve factual accuracy. Similarly, additional pre-training on general internet text introduces more generic data, not company-specific knowledge. Finally, using prompt examples alone cannot supply fresh or authoritative facts. Consequently, when we connect everything together, retrieval-augmented generation is the design change that best ensures accurate, relevant, and domain-specific answers. Question 8. For each statement below, indicate whether the answer is true or false. The goal of measurement is to establish a baseline and then track improvements after mitigations. True. A generalized workflow is prepare prompts, submit them, evaluate outputs using strict criteria. True. A classification model can be used to automate evaluation at scale. Correct answer. True. Automated testing replaces the need for any future manual checks. Correct answer. False. Now let us walk through the reasoning. Let us start with measurement. Establishing a baseline makes it possible to compare results over time. As mitigations are applied, improvements can be tracked quantitatively. Therefore, this statement is true. Next, let us look at the generalized workflow. Preparing prompts, submitting them, and evaluating outputs against defined criteria reflects a standard evaluation process. Consequently, this statement is also true. Now let us connect this to classification models. These models can automatically score and categorize outputs across large data sets. As a result, they are well suited for evaluation at scale. This makes the statement true. Finally, let us clarify the role of automation. While automated testing is powerful, it does not eliminate the need for periodic manual checks. Human review is still required to validate new scenarios and ensure accuracy. Therefore, this statement is false. Question 9. Before committing to a model, how can teams use platform support to make an informed choice? Select one answer. A. Rely on marketing materials alone. B. Explore public benchmarks for available models in the portal, then test finalists. C. Deploy immediately and decide later. D. Ignore benchmarks and pick the largest model. The correct answer is B. Explore public benchmarks for available models in the portal, then test finalists. Now let us look at the logic behind it. Let us start with the platform support piece. Public benchmarks in the portal give teams comparable performance data across models. Therefore, you can narrow down strong candidates using evidence instead of guesses. Next, let us connect this to testing finalists. Once you shortlist models, you validate them with your real workloads. Consequently, you confirm accuracy, cost, and latency before committing. By contrast, marketing materials alone are not proof. Deploying immediately skips evaluation. Similarly, picking the largest model can waste budget without guaranteeing the best fit. Therefore, exploring benchmarks first and then testing finalists is the most informed approach. Question 10. Arrange the steps to bootstrap evaluation data using an AI model in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Use an AI model to generate a subject-specific set of prompts and responses. Edit AI-generated prompts and responses to reflect desired outputs. Use the edited responses as ground truth to evaluate another model. Now let us break it down clearly. First, you generate a subject-specific set of prompts and responses using an AI model. This gives you a starting dataset aligned to the domain you want to evaluate. Next, you edit the AI-generated prompts and responses. Consequently, you correct mistakes, adjust wording, and align outputs with the standards you actually want to measure. Finally, you use the edited responses as ground truth. As a result, you can evaluate another model against consistent reference answers and measure quality more reliably. Question 11. You're wiring a flow to call external services? Security requires that secrets are never exposed to users while remaining reusable across nodes. Which two practices align with that requirement? Select two answers. A. Create prompt flow connections for each external service so tools reference them. B. Rely on hard-coded keys inside the LLM prompt to keep things simple. C. Let the connection securely store endpoint keys and credentials with secrets held in Azure Key Vault. D. Paste the API key into every node's input field for transparency. The correct answers are A. Create prompt flow connections for each external service so tools reference them. And C. Let the connection securely store endpoint keys and credentials with secrets held in Azure Key Vault. Here is why this answer fits. Let us begin with prompt flow connections. These connections centralize how external services are accessed. As a result, tools can reuse the same secure reference without ever exposing secrets to users or prompts. Next, let us connect this to secure storage. By storing endpoints and credentials in Azure Key Vault, secrets are protected and managed outside the flow logic. Consequently, this satisfies security requirements while keeping configurations reusable. By contrast, hard-coding keys inside prompts exposes sensitive data. Likewise, pasting API keys into every node spreads secrets and weakens security controls. Therefore, using prompt flow connections together with secure secret storage in Azure Key Vault is the correct and secure approach. Question 12. Which 3 items are called out as common pre-release compliance reviews? Select 3 answers. Legal, A, privacy, C, security, marketing. The correct answers are A, B, privacy, and C, security. Let us see how this works in practice. Let us begin with legal. This review ensures the solution complies with applicable laws, contracts, licensing terms, and liability requirements. As a result, it helps reduce legal risk before release. Next, let us look at privacy. Privacy reviews focus on how personal data is collected, used, stored, and shared. Consequently, this ensures alignment with privacy regulations and organizational commitments. Now let us connect this to security. Security reviews assess protections against threats and vulnerabilities. In real use, this includes evaluating data confidentiality, integrity, and access controls. By contrast, marketing focuses on promotion and messaging. It does not evaluate legal, privacy, or security compliance. Therefore, legal, privacy, and security are the correct pre-release compliance reviews. Question 13. Your team is deciding what telemetry to capture post-launch. They want to improve the product iteratively while staying compliant. Which 2 focus areas best align with the guidance? Select 2 answers. A. Track user satisfaction signals and patterns that reveal functional gaps or usability challenges. B. Collect personal data without consent to maximize model insights. C. Ensure telemetry collection complies with privacy laws and organizational policies. D. Limit telemetry to infrastructure costs only. The correct answers are track user satisfaction signals and patterns that reveal functional gaps or usability challenges, and C. Ensure telemetry collection complies with privacy laws and organizational policies. Here is the explanation. Let us begin with user satisfaction signals. Capturing feedback and usage patterns helps teams understand where users struggle or disengage. As a result, this data directly supports iterative improvements to functionality and usability. Next, let us connect this to compliance. Telemetry must always align with privacy laws and internal policies. Consequently, ensuring compliant data collection allows teams to improve the product responsibly without introducing legal or ethical risk. By contrast, collecting personal data without consent violates compliance requirements. Likewise, limiting telemetry only to infrastructure costs ignores insights needed to improve user experience. Therefore, focusing on user satisfaction signals while maintaining privacy compliance best aligns with the guidance. Question 14. For each statement below, indicate whether the answer is true or false. Azure AI Foundry Agent Service is part of Azure AI Foundry and provides a managed framework for creating and managing agents. Correct answer, true. Copilot Studio can only target Slack and Messenger channels, but not extend Microsoft 365 Copilot. Correct answer, false. Copilot Studio Agent Builder is available within Microsoft 365 Copilot Chat for creating basic declarative agents. Correct answer, true. The Microsoft Agent Framework helps implement multi-agent orchestration patterns. Correct answer, true. Let us understand why this is correct. Let us begin with Azure AI Foundry Agent Service. It is a managed service within Azure AI Foundry. As a result, it provides structured support for building, deploying, and managing agents. Therefore, this statement is true. Next, let us clarify Copilot Studio targeting. Copilot Studio is not limited to Slack or Messenger. In fact, it is also used to extend Microsoft 365 Copilot capabilities. Consequently, this statement is false. Now let us look at the Copilot Studio Agent Builder. This builder is available directly within Microsoft 365 Copilot Chat. In practice, it allows users to author simple declarative agents. Hence, this statement is true. Finally, let us connect this to the Microsoft Agent Framework. This framework is designed to support agent-based architectures. As a result, it enables orchestration patterns across multiple agents. Therefore, this statement is also true. Question 15. Fill in the blanks by selecting the correct options from the drop-down menus. The Azure AI Foundry Agent Service lets developers create, test, and manage agents through a visual portal or a code-first SDK. Here is the explanation. Let us begin with Azure AI Foundry Agent Service. This is the Azure native service designed to manage the full agent lifecycle. As a result, it supports creating, testing, deploying, and maintaining agents in a structured way. Next, let us look at the visual portal. This option provides a UI-driven experience. Consequently, it allows users to build and manage agents visually without deep coding requirements. Now let us connect this to the Code-First SDK. This option is intended for professional developers. In practice, it enables programmatic control, automation, and deeper customization using code. Therefore, the statement correctly highlights that Azure AI Foundry Agent Service supports both visual and code-first development approaches. Question 16. Fill in the blanks by selecting the correct options from the drop-down menus. Foundry Agent Service lets developers build agents by combining generative AI models with tools that interact with real-world data, while the platform reduces the amount of code required and manages the underlying infrastructure. Let us go step by step. Let us begin with generative AI models. These provide the reasoning and language capabilities that power the agent's responses. For example, the model can interpret a user request and decide what information is needed. Next, let us connect this to tools that interact with real-world data. These tools let the agent retrieve files, call search, or trigger functions to access live information. Consequently, the agent is not limited to what the model already knows. Now let us look at reduces the amount of code required. The service provides built-in orchestration, integrations, and agent patterns. As a result, developers do not need to write as much glue code to connect components manually. Finally, manages the underlying infrastructure. This means the platform handles the hosting and operational pieces behind the scenes. Therefore, teams can focus on building the agent experience rather than managing compute and storage details. Question 17. For each orchestration pattern in the Microsoft Agent Framework SDK, drag it to its correct description. Each item may be used once, more than once, or not at all. Broadcasts the same task to multiple agents and collects their results independently. Correct match. Concurrent orchestration. Passes the output from one agent to the next in a fixed sequence. Correct match. Sequential orchestration dynamically transfers control between agents based on context or rules. Correct match. Handoff orchestration coordinates a shared discussion among multiple agents and optionally humans. Correct match. Group chat orchestration uses a manager agent to plan, delegate, and adapt across specialized agents. Correct match. Magentic orchestration. Now let us see how this works in practice. Let us begin with concurrent orchestration. The same task is run in parallel across multiple agents. As a result, you can gather independent outputs quickly, which is useful for comparison or ensemble-style analysis. Next, sequential orchestration. Here, each agent's output feeds directly into the next agent. Consequently, this creates a step-by-step workflow where each stage builds on the previous result. Now consider handoff orchestration. Control moves between agents based on context or predefined rules. In real scenarios, this supports escalation, fallback, or routing to the most appropriate agent. Then, group chat orchestration Multiple agents participate in a shared conversation. Optionally, a human can join. This enables collaborative discussion coordinated within a single thread. Finally, magentic orchestration. A manager agent oversees the process. It plans tasks, delegates work, and adapts dynamically. Therefore, this pattern fits complex and open-ended problem solving. Question 18. For each statement below, indicate whether it is true or false. Sequential orchestration executes agents in a fixed, predefined order. Correct answer. True. Agents in a sequential workflow share results in real time with all other agents. Correct answer. False. Sequential orchestration is suitable for workflows like document review or data transformation pipelines. Correct answer. True. Sequential orchestration is inefficient when tasks can be executed independently or in parallel. Correct answer. True. True. Let us understand why this is correct. To begin with the execution order, sequential orchestration is designed so agents run one after another in a strict sequence. Each step depends on the previous one. Therefore, this statement is true. Now consider result sharing. In a sequential workflow, agents do not broadcast results in real time. Each agent only receives the output from the prior step. As a result, this statement is false. Next, let us look at real-world use cases. Document review and data transformation often require step-by-step refinement. Consequently, sequential orchestration fits these scenarios well. This makes the statement true. Finally, let us examine efficiency. When tasks do not depend on each other, running them sequentially adds unnecessary delay. Hence, sequential orchestration becomes inefficient in parallelizable workloads. Therefore, this statement is true. Question 19. Arrange the following steps in the agent's dynamic function calling interaction in the correct order. Instruction. Drag and drop the items into the correct order. Starting with the first step at the top, a user asks a question requiring computed or retrieved data. The agent decides to invoke a predefined function and supplies arguments. The function runs, optionally contacting other APIs, and returns a result. The agent uses the returned result to answer the user. Let us see how this works in practice. First, the interaction begins when a user asks a question that cannot be answered using reasoning alone. This signals that external computation or data retrieval is needed. Next, the agent evaluates the request and determines that a predefined function should be called. As a result, it prepares and supplies the appropriate arguments. Then, the function executes. In some cases, it may contact external APIs or services. After execution, it returns a structured result. Finally, the agent incorporates the returned result into a clear response. Consequently, the user receives an accurate and data-backed answer. Question 20. In the Model Context Protocol, how are tools defined conceptually? Select one answer. A, as debugging utilities for monitoring agent errors. B, as static libraries compiled directly into the language model. C, as primitive types that expose executable functionality to clients. D, as optional metadata fields for documenting agent requests. The correct answer is as primitive types that expose executable functionality to clients. Let us look at the logic behind it. To begin with the Model Context Protocol, tools are treated as first-class primitives. This means they define executable capabilities that clients can invoke through a standard interface. In practice, this allows an agent or client to call server-side functions in a structured and predictable way. Thus, consequently, tools are not just descriptive or supportive elements. By contrast, debugging utilities focus on diagnostics. Static libraries would be hard-coded into the model, and metadata fields are only for documentation. Therefore, defining tools as primitive types that expose executable functionality best reflects how tools are conceptualized in the Model Context Protocol. Question 21. A software company wants to design an AI system that runs multiple analyses on customer feedback simultaneously to improve accuracy. Each analysis agent works independently, and their combined insights form the final report. Which orchestration pattern would best fit this design? Select one answer. A, concurrent orchestration. B, sequential orchestration, C, handoff orchestration, D, group chat orchestration? The correct answer is A, concurrent orchestration. Let us see how this works in practice. In this scenario, multiple agents are analyzing the same data at the same time. Each agent operates independently and produces its own results. As a result, running them in parallel improves speed and overall accuracy. Now, let us connect this to concurrent orchestration. This pattern is designed specifically to broadcast tasks across multiple agents simultaneously. Consequently, it allows insights to be gathered independently and then combined into a single output. By contrast, sequential orchestration runs agents one after another. Handoff orchestration focuses on transferring control, and group chat orchestration centers on shared conversation rather than parallel analysis. Therefore, concurrent orchestration is the best fit for this design. Question 22. A development team is tuning their Magentic orchestration system. They notice that after several agent interactions, progress slows significantly. They want to adjust orchestration behavior to limit how many collaboration rounds occur before resetting the process. Which configuration settings should they modify? Select one answer. A, maximum stall count. B, maximum round count. C, dynamic task ledger limit. D, streaming callback frequency. The correct answer is B, maximum round count. Let us look at the logic behind it. In this situation, the issue is too many collaboration cycles occurring before the system resets. Therefore, the control needed must directly limit the total number of interaction rounds. Maximum round count does exactly that. It caps how many planning and collaboration iterations can occur. As a result, the orchestration can stop or reset before progress degrades. By contrast, maximum stall count only limits inactive or stuck steps. Dynamic task ledger limit does not numerically restrict collaboration cycles. And streaming callback frequency relates to event handling rather than orchestration flow. Consequently, adjusting the maximum round count is the correct way to control collaboration depth and maintain performance. Question 23. A company is integrating multiple autonomous agents that process confidential financial information to protect sensitive data while enabling reliable collaboration. The solution must ensure that all inter-agent communication occurs through a standardized, secure communication framework rather than ad hoc connections. Which approach should the company implement? Select one answer. A, configure manual routing between all agents. B, implement the agent-to-agent A2A protocol for secure communication. C, use unencrypted HTTP endpoints for faster messaging. D, deploy each agent separately without coordination. The correct answer is B, implement the agent-to-agent A2A protocol for secure communication. Let us see how this works in real use. In this scenario, the primary concern is protecting confidential financial data while agents collaborate. Therefore, communication must be standardized, secure, and governed by a trusted framework. The agent-to-agent A2A protocol is designed specifically for this purpose. It enables agents to exchange information through secure, well-defined channels. As a result, data is protected during transmission and collaboration remains reliable. By contrast, manual routing increases complexity and security risk. Unencrypted HTTP exposes sensitive data, and deploying agents without coordination prevents secure collaboration entirely. Consequently, implementing the agent-to-agent A2A protocol is the correct and secure approach. Question 24. Which two built-in capabilities are provided by the AI agent service for extending an agent's functionality? Select two answers. A, human approval workflows. B, pricing automation. C, knowledge gathering. D, code generation. The correct answers are C, knowledge gathering, and D, code generation. Let us connect this to how it works in real use. To begin with, knowledge gathering allows an agent to retrieve and use information from relevant sources. This enables the agent to ground its responses in accurate, up-to-date context, rather than relying only on prior knowledge. Next, code generation is a built-in capability that lets the agent create or suggest code automatically. As a result, Developers can extend agent behavior quickly without writing everything manually. By contrast, human approval workflows and pricing automation are not provided as built-in capabilities of the AI agent service. Therefore, knowledge gathering and code generation are the correct choices for extending agent functionality. Question 25. Your engineering team is overwhelmed with incoming support tickets for bugs, feature requests, and infrastructure issues. You want to speed up response times by automating triage without writing custom orchestration logic. What approach would best meet this goal? Select one answer. A. Use a single general-purpose agent to handle classification, prioritization, and routing of tickets. B. Implement a multi-agent system where a primary agent delegates tasks to specialized subagents. C. Scale up the single agent with more resources so it can handle a wider variety of tasks. D. Build a custom orchestration engine to route tickets to different scripts. The correct answer is B. Implement a multi-agent system where a primary agent delegates tasks to specialized subagents. Let us see how this works in practice. In this scenario, the challenge is handling many different ticket types quickly without adding orchestration complexity. Therefore, the solution should divide responsibilities while remaining easy to manage. A multi-agent system does exactly that. A primary agent can triage incoming tickets, then delegate bug analysis, feature evaluation, or infrastructure checks to specialized subagents. As a result, each task is handled efficiently without custom orchestration code. By contrast, a single general-purpose agent becomes harder to maintain as responsibilities grow. Scaling resources alone does not solve workflow complexity, and building a custom orchestration engine adds unnecessary development overhead. Consequently, using a multi-agent system with delegated specialization is the most effective and scalable approach. Question 26. When multiple tools are registered with a single Azure AI Foundry agent, how does the framework determine which tool to call? Select one answer. A. The framework automatically selects the appropriate tool based on the user's request. B. The developer must manually choose the tool to call during every conversation. C. Tools are called randomly by the framework for variety in responses. D. The user must specify the exact function name before it can be called. The correct answer is A. The framework automatically selects the appropriate tool based on the user's request. Now let us look at the logic behind it. At runtime, the framework evaluates the user's input and intent. It then matches that intent against the capabilities and metadata of the registered tools. As a result, the most relevant tool is selected automatically without manual intervention. This automatic selection enables seamless function calling. Developers do not need to hardcode decisions, and users do not need to know tool or function names. By contrast, manual selection would defeat automation. Random selection would break reliability, and forcing users to name functions would reduce usability. Therefore, the framework's ability to automatically choose the correct tool based on the user's request is the correct and intended behavior. Question 27. Which statement accurately describes how orchestration patterns can be applied across different environments? Select one answer. A. They only function within Azure-specific services. B. They are technology agnostic and can integrate into diverse systems and domains. C. They require custom rewrites for every different domain. D. They depend on a single proprietary orchestration environment. The correct answer is B. They are technology agnostic and can integrate into diverse systems and domains. Now let us connect this to how it works in real use. Orchestration patterns describe how agents collaborate, not where they must run. As a result, the same patterns can be applied across different platforms, architectures, and industries. Because they are technology agnostic, teams can reuse these patterns in hybrid or cross-platform environments without redesigning the workflow. By contrast, limiting them to Azure-only services, requiring rewrites for every domain, or tying them to a single proprietary environment would eliminate their reusability. Therefore, orchestration patterns are designed to integrate flexibly across diverse systems and domains. Question 28. Fill in the blanks by selecting the correct options from the drop-down menus. To use Azure AI Language, you must first provision a resource in your Azure subscription, and then use its endpoint and key to call the APIs. Let us see how this works step by step. Let us begin with provisioning a resource. Azure AI Language capabilities are enabled by creating a dedicated Azure resource. This resource represents the service instance you will interact with. Next, this resource must exist within an Azure subscription. The subscription manages access, billing, and permissions for all Azure services. Therefore, it forms the administrative boundary for using Azure AI Language. Finally, once the resource is created, you use the endpoint and key. These credentials authenticate your requests and allow your application to securely call the Azure AI Language APIs. As a result, provisioning a resource in an Azure subscription and using its endpoint and key is the correct and complete process for accessing Azure AI Language. Question 29. For each statement below, indicate whether it is true or false. Each call to an Azure AI Language resource must include the key in the OCP APIM subscription key header. Correct answer. True. The REST API deployment request returns a 200 OK response immediately after model submission. Correct answer. False. The job status succeeded indicates that deployment is complete. Correct answer. True. The placeholders, project name, and deployment name are case insensitive. Correct answer. False. Let us clarify the reasoning. To begin with, authentication. Azure AI Language requests require the OCP APIM subscription key header. This header carries the resource key used to authenticate every API call. Therefore, this statement is true. Next, consider deployment responses. Deployment requests are asynchronous. As a result, the API returns a 200 to accepted response rather than 200 OK. Hence, this statement is false. Now let us connect this to job status. When the job status shows succeeded, it confirms that deployment is finished successfully. Consequently, this statement is true. Finally, regarding placeholders. Placeholder names are case-sensitive and must match exactly as defined. Because of this strict requirement, the statement claiming they are case-insensitive is false. Question 30. For each intent, drag it to the corresponding example utterance pattern in the correct match column. Each item may be used once, more than once, or not at all. Turn on a specified device. Correct match. Turn on device. Ask whether a device is currently on. Correct match. Get device status. Turn off a specified device. Correct match. Turn off device. Let us understand why these matches are correct. To begin with, turn on device. This intent captures user requests that explicitly ask to power on a device. In real use, phrases like turning on or switching on a device map directly to this intent. Therefore, it is the correct match for turning a device on. Next, let us look at get device status. This intent is used when a user is asking about the current state of a device. For example, checking whether a device is already on fits naturally into a status query. Consequently, this intent correctly matches questions about device state. Finally, let us connect this to turn off device. This intent represents commands that power down a device. Requests to turn off or switch off a device align directly with this action. Hence, turn off device is the correct match here. As a result, each intent aligns cleanly with the user's underlying goal, enabling accurate intent recognition and reliable device control. Question 31. Match each pre-built entity type with what it automatically detects. Each item may be used once, more than once, or not at all, detects email addresses and user input. Correct match. Email entity. Recognizes numeric values such as quantities or counts. Correct match. Number entity. Identifies website links shared in text. Correct match. URL entity. Let us understand why these matches are correct. Let us begin with the email entity. This pre-built entity is designed to automatically recognize standard email address formats in user input. As a result, it reliably extracts email information without manual pattern definitions. Next, the number entity focuses on numeric values. It can identify quantities, counts, and numbers expressed in different forms. Consequently, it is ideal for capturing numerical input consistently. Finally, The URL entity detects web links included in text. This allows systems to recognize and process website references accurately. Therefore, it is the correct match for identifying website links. In summary, each pre-built entity type automatically detects a specific kind of structured data, making intent recognition and data extraction more accurate and efficient. Question 32. Fill in the blanks by selecting the correct options from the drop-down menus. In Azure AI Speech, the voice used for synthesis is specified by setting the speech synthesis voice name, property of the speech config object. Let us understand why this is correct. To begin with, speech synthesis voice name defines which voice is used during text-to-speech synthesis. By setting this property, you control the voice identity that produces the spoken output. Next, the speech config object is where synthesis settings are configured. In practice, it holds properties related to voice selection, output format, and other speech parameters. As a result, specifying the voice through the speech synthesis voice name property on the speech config object is the correct and intended way to configure speech synthesis in Azure AI Speech. Question 33. Arrange the steps involved in building and deploying a conversational language understanding model in the correct sequence. Instruction: drag and drop the items into the correct order, starting with the first step. Create an Azure AI language resource. Import and train your data. Deploy the trained model. Query the model for predictions. Let us go step by step. First, you create an Azure AI language resource. This sets up the cloud environment and infrastructure required for model development. Next, you import and train your data. Here, labeled utterances and intents are used to teach the model how to understand user input. Then, you deploy the trained model. Deployment makes the model available through an endpoint for real-time use. Finally, you query the model for predictions. At this stage, applications send user input to receive intent and entity recognition results. Question 34. For each statement below, indicate whether it is true or false. The Azure AI Speech Service includes APIs for speech recognition, synthesis, translation, keyword recognition, and intent recognition. Correct answer: true. You must create a speech resource before using any speech API features. Correct answer: true. The resource key and location are optional when using the speech SDK. Correct answer: false. The speech config object is used to configure speech settings, including resource connection details. Correct answer: true. Let us understand why this is correct. To begin with the Azure AI Speech Service capabilities, the platform provides APIs that cover recognition, synthesis, translation, keyword spotting, and intent recognition. Therefore, this statement is true. Next, consider resource creation. A speech resource must exist in an Azure subscription before any API calls can be authenticated. As a result, this statement is also true. Now let us clarify the use of keys and location. When using the Speech SDK, both the resource key and region are required to establish a connection. Consequently, saying they are optional is incorrect, making this statement false. Finally, let us look at speech config. This object encapsulates configuration settings, such as the subscription key, region, and other speech options. Hence, it is correctly described, and the statement is true. Question 35. A developer wants two neural voices to alternate lines in a scripted dialogue, one cheerful, one neutral, within a single synthesized output. Which approach best achieves this? Select one answer. A. Define a single voice element and change its name property midway through the audio stream. B. Include multiple voice elements within one SSML document, each specifying a different voice name. C. Set multiple audio formats for each paragraph. D. Run separate synthesizer sessions for each line and merge the files manually. The correct answer is B. Include multiple voice elements within one SSML document, each specifying a different voice name. Let us see how this works in practice. SSML is designed to support multiple voice elements in a single document. Each voice tag can specify a different neural voice, allowing the speech engine to switch speakers naturally between lines. By contrast, a single voice element cannot change its voice name midway. Audio formats control encoding, not speaker identity, and merging separate audio files adds unnecessary complexity. Therefore, using multiple voice elements within one SSML document is the correct and most efficient approach for alternating voices in a single synthesized output. Question 36. A developer is building an audio-based chat feature. The model must process prompts containing both text and audio from the user. The developer decides to include a URL to a hosted MP3 file in the user message. Which type of content should the developer include in the prompt to meet this requirement? Select one answer. A. Text-only message. B. Binary data stream. C. Audio URL. D. Base64 encoded data. The correct answer is C. Audio URL. Let us see how this works in real use. When an audio file is already hosted, providing an audio URL allows the model to access and interpret the external audio resource directly. This makes it possible to process spoken input alongside text in the same prompt. By contrast, a text-only message contains no audio. Binary data streams are not supported in chat prompts, and Base64 encoding is only used when embedding raw audio data directly rather than referencing a hosted file. Therefore, including an audio URL is the correct and intended approach for supplying hosted audio content to the model. Question 37. For each statement below, indicate whether the answer is true or false. The max response output token setting defines the upper limit of model-generated tokens. Correct answer, true. Setting max response output tokens to inf allows unlimited token output. Correct answer, true. The instructions field customizes the assistant's personality or response behavior. Correct answer, true. The instructions field is automatically generated by the API and cannot be changed. Correct answer, false. Now let us clarify the reasoning. To begin with output, the max response output tokens parameter explicitly controls how many tokens the model is allowed to generate in a single response. Therefore, this statement is true. Next, consider the use of inf. Setting the value to inf removes the token ceiling. As a result, the model is not constrained by a fixed output length. This makes the statement true. Now let us look at instructions. The instructions field is used to guide tone, style, and overall response behavior. For example, it can specify whether the assistant should be concise or detailed. Consequently, this statement is true. Finally, regarding configurability, the instructions field is not auto-generated by the API. It is fully user-defined and can be modified as needed. Therefore, the statement claiming it cannot be changed is false. Question 38. A software company is developing a customer feedback analysis system. They want to automatically determine whether customer reviews express satisfaction or dissatisfaction with their products. Which Azure AI language feature should they use? Select one answer. A. Sentiment analysis. B. Named entity recognition. C. Key phrase extraction. D. Language detection. The correct answer is A. Sentiment analysis. Now let us look at the logic behind it. Sentiment analysis is specifically designed to evaluate the emotional tone of text. It determines whether feedback is positive, negative, or neutral, which directly aligns with identifying customer satisfaction or dissatisfaction. By contrast, named entity recognition focuses on identifying names or places. Key phrase extraction highlights important topics, and language detection only identifies the language used. None of these assess opinion or emotional tone. Therefore, sentiment analysis is the correct feature for understanding how customers feel about a product based on their reviews. Question 39. What happens when a knowledge base is deployed from Language Studio? Select one answer. A. It converts all Q&A pairs into SQL database tables. B. It removes the ability to test the knowledge base. C. It automatically creates multiple instances across all Azure regions. D. It is published to a REST endpoint that client applications can use to submit questions and receive answers. The correct answer is D. It is published to a REST endpoint that client applications can use to submit questions and receive answers. Now let us connect this to how it works in real use. When a knowledge base is deployed from Language Studio, The deployment step exposes it through a REST API endpoint. This endpoint allows external client applications, such as chatbots or web apps, to send questions and receive answers programmatically. By contrast, deployment does not convert content into SQL tables, does not remove testing capabilities, and does not automatically replicate the knowledge base across all Azure regions. Therefore, publishing the knowledge base to a REST endpoint is the key outcome of deployment, enabling real-world application integration. Question 40. In an Azure AI language classification project, which metadata fields primarily serve as descriptive identifiers for human reference and do not affect the model's technical configuration, select one answer. A, project kind and dataset. B, project name and description. C, string index type and UTF-16 code unit. D, language and storage input container name. The correct answer is B, project name and description. Now let us look at the logic behind it. The project description fields exist to label and as the project for human users. They help teams recognize, organize, and document projects without influencing how the model is trained, configured, or executed. By comparison, project kind and dataset affect how data is structured and used. String index type and UTF-16 code unit control how text positions are interpreted, and language with storage input container name define document language and data location, all of which directly impact technical behavior. Therefore, project name and description are purely descriptive metadata, making them the correct choice. Question 41. What two actions are part of setting up an Azure AI speech resource for translation? Select two answers. A, deploy the resource to a selected Azure region. B, generate and use at least one authentication key. C, configure a database to store transcriptions. D, enable network peering between regions. The correct answers are A, deploy the resource to a selected Azure region, and B, generate and use at least one authentication key. Let us connect this to how it works in real use. To begin with deployment, every Azure AI speech resource must be created in a specific Azure region. This determines where the service runs and is a required step before any translation features can be used. Next, authentication. At least one subscription key must be generated and supplied in requests. This key allows the SDK or REST API to authenticate calls securely. Without it, the service cannot be accessed. By contrast, configuring a database is optional and application-specific, not required for translation. And network peering between regions is unrelated to setting up the speech service itself. Therefore, deploying the resource to a region and generating an authentication key are the two required actions for setting up Azure AI speech translation. Question 42. As of version 1.0.0 of the Python client library, what is the accurate statement? Select one answer. A, the library supports both synchronous and asynchronous usage equally. B, the synchronous API has been deprecated. The library is async only and uses async/await. C, async is optional. Synchronous usage remains the recommended approach for production. D, only the event loop is async. All network calls are synchronous. The correct answer is B. The synchronous API has been deprecated. The library is async only and uses async/await. Let us break it down clearly. The key point is that version 1.0.0 focuses on asynchronous patterns. This means API usage is built around async and await, and synchronous calling patterns are no longer supported as the primary interface. By contrast, if both sync and async were equally supported, there would be no deprecation. Likewise, saying async is optional or that network calls remain synchronous contradicts how an async-only client works. Therefore, the accurate statement is that the synchronous API is deprecated and the library is async only using async and await. Question 43. Which two types of features does the Azure AI Language Service provide? Select two answers. Pre-configured features. B, unsupervised clustering features. C, learned features. D, neural rendering features. The correct answers are A, pre-configured features, and C, learned features. Let us walk through the explanation. To begin with pre-configured features, these are ready-to-use capabilities such as sentiment analysis, key phrase extraction, and language detection. They work out of the box without requiring you to train a custom model. Next, learned features. These are features that require training with labeled data. Examples include custom text classification or conversational language understanding, where the model learns patterns specific to your domain. On the other hand, unsupervised clustering is not a feature of Azure AI language, and neural rendering relates to visual or generative media, not natural language understanding. Therefore, the Azure AI Language Service provides both pre-configured features and learned features, giving developers flexibility between ready-made analysis and custom-trained solutions. Question 44. When using the Azure AI Speech SDK for speech synthesis, which two objects are required to create a speech synthesizer instance? Select two answers: A, speech config, B, speech voice setting, C, speech recognition config, D, speech synthesis result, E, audio config. The correct answers are A, speech config, and E, audio config. Let us go step by step. First, speech config is required because it contains the Azure Speech Resource Connection details, including the subscription key and region. Without this, the SDK cannot authenticate or connect to the service. Next, audio config defines where the synthesized audio will be sent, such as a speaker, audio file, or output stream. This makes it essential for controlling how the generated speech is delivered. By contrast, speech voice setting is not a standalone SDK object. Speech recognition config is used for speech-to-text scenarios, and speech synthesis result represents the output after synthesis, not a required input. Therefore, creating a speech synthesizer instance requires speech config and audio config, which together handle connection and audio output configuration. Question 45. Which SSML element is used to apply an expressive tone, such as cheerful or sad, to a neural voice? Select one answer. A, memesties express as, B, voice, C, prosody, say as. The correct answer is A, mistats express as. Here is why this answer fits. The MSTs express as element is specifically designed to control expressive speaking styles in neural voices. It allows you to apply tones such as cheerful, sad, excited, or calm, directly influencing how the voice conveys emotion. By comparison, the voice element only selects which voice is used. Prosody adjusts pitch, rate, and volume, but not emotional style. And say as is used for formatting how structured content like dates or numbers is spoken. Therefore, MST express as is the correct SSML element for applying expressive tone to a neural voice. Question 46. Fill in the blanks by selecting the correct options from the drop-down menus. Face attribute analysis can return values such as head pose orientation, glasses type, and presence of a mask. These results help applications understand a person's appearance and visual conditions in an image. Now let us break it down clearly. Face attribute analysis examines visual characteristics of a detected face. Head pose orientation describes the three-dimensional positioning of the face, such as whether it is turned or tilted. In addition, glasses type identifies the kind of eyewear a person may be wearing. For example, reading glasses or sunglasses. Presence of a mask determines whether a face covering is detected. Taken together, these attributes provide insight into a person's appearance and the visual conditions captured in the image, enabling applications to better interpret facial presentation and context. Question 47. For each statement below, indicate whether the answer is true or false. The portal's interactive labeler can suggest regions that likely contain objects. Correct answer: true. The smart labeler can start suggesting object classes before any training. Correct answer: bounding boxes are defined by left, top, width, and height. Correct answer. True. Values for bounding boxes are given as proportions relative to the source image size. Correct answer. True. Let us look at the logic behind it. To start with the interactive labeler, it can automatically propose candidate regions in an image, helping users label objects more efficiently. This makes the first statement true. Next, the smart labeler. It relies on a trained model, so it cannot suggest object classes before any training has occurred. Therefore, that statement is false. Now, consider bounding box structure. Bounding boxes are defined using left and top coordinates along with width and height, which describe position and size. This confirms the third statement is true. Finally, bounding box values are normalized, meaning they are expressed as proportions between 0 and 1 relative to the image size. This ensures consistency across different resolutions, making the final statement true. Question 48. For each statement below, indicate whether the answer is true or false. ARM templates cannot be used to create a video indexer resource. Correct answer? False. Widgets allow you to embed the video indexer player and insights in your own HTML pages without granting full portal access. Correct answer? True. The auth endpoint includes both the account's location and account ID in its URL path. Correct answer? True. A valid access token is required to call REST endpoints, such as videos or custom logos. Correct answer. True. Let us see how this works in practice. First, ARM templates. They can be used to provision a video indexer resource programmatically. So saying they cannot be used is incorrect, making the first statement false. Next, widgets. These are designed to embed video indexer players and insights directly into custom web pages, while controlling access, which makes the second statement true. The auth endpoint, its URL structure includes both the Azure region location and the specific account ID. So this statement is also true. Finally, REST API access. Operations such as listing videos or retrieving custom logos require a valid access token. Without it, requests are not authorized, confirming the final statement as true. Question 49. For each description, drag the correct term into the correct match column. Each item may be used once, more than once, or not at all. HTTP header that carries the API key for calling the model. Correct match. Authorization, network destination to which the request is sent. Correct match. Endpoint, request parameter that specifies number of images. DAL-E3 constraint applies. Correct match. N, Unix timestamp returned with the image generation response. Correct match. Created. Field containing the link to the generated PNG image. Correct match. URL. Field containing the system updated text actually used to generate the image. Correct match. Revised prompt. Let us break it down clearly. Authorization is the header the client sends so the service can authenticate the request. Without a valid key in this header, the request is rejected and no image generation occurs. Next, endpoint is the service address the client targets. This is the URL where the image generation request is submitted, so choosing endpoint fits anything describing the network destination. Now, N controls the number of images requested in a single call. The key detail here is the DAL-E3 constraint, which means N must be set to 1. Therefore, N is the only correct match for the image count parameter. Created is returned by the service as a Unix timestamp. This timestamp is part of the response metadata, and it helps you track when the generation was produced. URL is the response field that holds the direct link to the generated PNG image. In practice, your app can use this link to display the image or download it for storage. Finally, revised prompt is the system-adjusted prompt text. It shows the final wording the model actually used to generate the image, which is useful for understanding how the request was interpreted and why the output looks the way it does. Question 50. A developer submits a DAL-E3 request with N4 because they want 4 variations at once. The call fails validation. What change enables a successful request while keeping the single call approach? Select one answer. A. Add the API key to the query string instead of the header. B. Switch the response mode to asynchronous and keep N 4. C. Set N to 1 because DAL-E3 only supports a single image per request. D. Include revised prompt true. The correct answer is C. Set N to 1 because DAL-E3 only supports a single image per request. Let us break it down clearly. DAL-E3 enforces a constraint on the N parameter, meaning only one image can be generated per request. Therefore, setting N to 4 fails validation, even if everything else in the request is correct. When you change N to 1, the request aligns with the model's supported behavior, and the call succeeds while still remaining a single API request. By contrast, moving the API key into the query string does not fix the validation issue and also weakens secure authentication. Switching to asynchronous mode does not change the DAL-E3 limitation on N, and revised prompt is a response field returned by the system, not a request setting you can enable. Consequently, the only valid change that keeps a single call is setting N to 1. Question 51. An app calls the classification API using a valid project ID, but the request fails because the published model name cannot be found. What should be done to enable predictions? Select one answer. A. Switch to the training resource key. Training keys are required for predictions. B. Remove the model name. The service will pick the newest model automatically. C. Publish the trained model to the prediction resource and reference that published model name in the request. D. Use object detection instead of classification to avoid publishing. The correct answer is C. Publish the trained model to the prediction resource and reference the published model name in the request. Now let us look at the logic behind it. Prediction calls can only run a model that has been published. So even if the project ID is valid, the API still needs a published model name that exists in the prediction resource. If that name cannot be found, it means the model was not published, or the request is referencing a name that does not match the published iteration. Now let us compare that with the other choices. Using the training resource key does not help because prediction requests must use the prediction resource and its key, not training credentials. Removing the model name also does not work because the classification prediction API expects a specific published model name. It does not auto-select the newest model for you. Switching to object detection changes the task, but it still would require publishing a trained model before predictions can run. Therefore, the correct fix is to publish the trained model to the prediction resource, and then reference that exact published model name in the request. Question 52. What using directive is required in C# to access custom vision prediction client for prediction calls? Select one answer. Using Microsoft Azure.CognitiveServices.Vision Custom Vision Training. B. Using Microsoft Azure Cognitive Services.Vision.Custom Vision Prediction. C. V. Using Azure AI Vision Custom. D. Using Microsoft Azure ML Custom Vision. The correct answer is B. Using Microsoft.Azure Cognitive Services.Vision Custom Vision.Prediction. Now let us break it down clearly. Custom Vision Prediction Client belongs to the prediction namespace. So you must import Microsoft.Azure Cognitive Services.Vision.CustomVision.Prediction to access the client and make prediction calls. On the other hand, the training namespace is used for training operations, not for running predictions. And the other namespaces listed are not the correct SDK namespace for custom vision prediction in this context. Therefore, the required using directive is Microsoft Azure.Cognitive Services Vision.CustomVision.Prediction. Question 53. Which statement best describes how image-based prompts are tested in Azure AI Foundry? Select one answer. A. Images are converted into binary files that can't be viewed during testing. B. Users upload an image and add text messages in the chat playground. Images must be hosted on a web server before the model can process them. D. Image testing requires exporting the model to Visual Studio Code. The correct answer is B. Users upload an image and add text messages in the chat playground. Here's what makes this correct. Azure AI Foundry's chat playground supports multimodal testing, allowing users to upload an image directly and combine it with text in a single interactive prompt This makes it easy to experiment with image-based inputs and immediately observe model responses without additional setup. By contrast, converting images to hidden binaries is not how testing works. Hosting images externally is optional rather than required. And exporting to Visual Studio Code is unnecessary because testing is performed directly in the Foundry portal. Therefore, the correct description is that users upload an image and add text messages in the chat playground. Question 54. Fill in the blanks by selecting the correct options from the drop-down menus. Custom analyzers built with the service aim to extract insights from varied content and then generate outputs that automate and optimize organizational processes. This fits because automate indicates that analyzer outputs are designed to trigger or support hands-off workflows and actions without manual intervention. Optimize reflects the goal of using extracted insights to improve efficiency, streamline operations, and enhance decision-making across the organization. Options such as complicate or postpone do not align with the service's purpose. The focus is on improving and accelerating processes, not adding friction or delay. Therefore, the correct completions are automate and optimize. Question 55. Arrange the following query stages in the correct sequence, followed by Azure AI Search when processing a query. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Query parsing, lexical analysis, document retrieval, scoring. Now let us go step by step. The process starts with query parsing, where Azure AI Search interprets the structure of the query, including syntax, operators, and intent to understand what the user is requesting. This is followed by lexical analysis, in which the query text is tokenized and normalized, ensuring the terms align with how content is indexed. Next, document retrieval takes place, where the search engine scans the index to identify documents that match the parsed and analyzed query terms. At the final stage, scoring is applied, ranking the retrieved documents based on relevance signals, so the most relevant results are returned first. Question 56. A developer submits a put request to create an analyzer and receives a response containing an operation location header. What should they do next? Select one answer. A. Immediately issue another put request with the same schema to confirm creation. B. Wait for an email confirmation that the analyzer was created. C. Use GET requests to the operation location URL to check status until the analyzer creation is complete. D. Assume completion because the put returned 200 OK. The correct answer is C. Use GET requests to the operation location URL to check status until the analyzer creation is complete. Now let us look at the logic behind it. When you receive an operation location header, it means the operation is running asynchronously. In other words, the service is telling you where to poll for status updates. So the next step is to send GET requests to that operation location URL until the status shows the analyzer creation has finished. By contrast, sending another put request can create duplicate operations instead of confirming completion. Waiting for an email does not apply because this workflow is API-driven. And even if you see a 200 OK, that only confirms the request was accepted, not that the analyzer is fully created and ready to use. Therefore, polling the operation location URL with GET requests is the correct next action. Question 57. Drag each ID-specific attribute to the document type that immutably contains it. Each item may be used once, more than once, or not at all. Endorsements, restrictions, vehicle classifications, correct match, U.S. driver's license, machine readable zone, MRZ, on the biographical page. Correct match, international passport. Now let us connect this to how it works in real use. Endorsements, restrictions, and vehicle classifications are fields that appear on a driver's license because they describe what the license holder is permitted to drive and any limits placed on them. That information is license-specific, so it maps directly to a U.S. driver's license. Next, the machine-readable zone is a standardized set of characters printed on the biographical page of a passport. It is designed for fast scanning at borders and checkpoints. So when you see MRZ on the bio page, it immutably points to an international passport. Meanwhile, receipt, invoice, and business card models do not represent ID document types that contain endorsements or an MRZ. They are built for extracting transactional or contact information, not identity attributes. Question 58. What does it mean when a skill in an enrichment pipeline runs within a specific context of a document hierarchy? Select one answer. A. It runs once for the entire data source regardless of document structure. B. It can modify unrelated documents during the same indexing job. C. It executes randomly on any document field available in the index. D. It operates on a defined level of the document, such as each image within a collection. The correct answer is D. It operates on a defined level of the document, such as each image within a collection. Here is why this answer fits. In an enrichment pipeline, a skill's context tells Azure AI Search exactly where that skill should run in the document hierarchy. So instead of running one time for the whole data source, it runs at a specific level, such as once per item in a collection, like each image, each page, or each record inside a nested structure. Now let us compare it with the other choices. If it ran once for the entire data source, the hierarchy would not matter. But skill contexts exist specifically to target structured parts of a document. It also cannot modify unrelated documents, because skills operate within the current document being indexed, not across other documents in the same job. And it does not execute randomly, because the context explicitly defines the path and scope where the skill applies. Therefore, the correct meaning is that the skill operates on a defined level of the document hierarchy, such as each image within a collection. Question 59. Which statement best describes custom skills in an Azure AI search enrichment pipeline? Select one answer. They allow users to apply their own processing logic to extracted data before it's added to the index. B. They replace built-in skills with faster versions provided by Microsoft. C. They can only run using Azure AI Vision. They are used only for translating text into different languages. The correct answer is A. They allow users to apply their own processing logic to extracted data before it's added to the index. Here is why this answer is correct. Custom skills extend the enrichment pipeline by letting you run your own processing logic. For example, calling an Azure function or another service to create new fields or transform extracted content, before that enriched output is stored in the search index. Let's look at why the other options do not fit. B suggests replacement, but custom skills are user-defined additions that work alongside built-in skills, not faster Microsoft replacements. C is too limiting, because custom skills can call many services beyond Azure AI Vision. D is too narrow. Translation is a specific built-in skill capability, while custom skills are for any custom enrichment you want to add. Question 60. You want to reuse labels created in another project. What constraint must be met when supplying the labels file to a new project? Select one answer. A. The file must store all text directly in the entity's labels nodes. B. The file must include analysis time fields like display name and tasks. C. The file must use an accepted custom NIR data format for import. D. The file must be in CSV with UTF-8 BOM. The correct answer is C. The file must use an accepted custom NIR data format for import. Here is why this answer is correct. Azure AI language projects only accept label files that follow the supported custom named entity recognition import schemas. Using an accepted format ensures the service can correctly interpret entity spans, labels, and document structure when reusing labels across projects. Let's look at why the other options do not fit. A. Labels reference entity spans, not full raw document text, storing all text in entities. Labels is not how labeling files are structured. B. Display name and tasks are request time analysis fields. They are not required or valid in label import files. CSV with UTF-8 BOM is not a supported format for custom any or label imports. The service expects specific JSON-based schemas,